everyone, in this video I just wanted to go through one more example of the difference quotient. So this was the last example on the in-class worksheet, this function here. And remember that the difference quotient is this quantity here, and the key for us is just to interpret what should this look like if this is the function that we're given. And probably the hardest part of this is understanding this notation, this g of x plus h. So remember our function notation. If I said, say, g of 0, what that means is I'm just going to take 0 and plug it into the function. In this case, that would be 3 times 0 squared minus 4 times 0 plus 7, or this would come out to 7. Same thing if I wanted g of 1. We'd just plug 1 in. Same kind of process. Now in this case, these both come out to be numbers. G of x plus h is the same notation, we're just not going to get a number value. So this is saying take the g function and plug in x plus h as the input. So for this function, the g of x plus h is going to look like 3 times, we're plugging in x plus h squared minus 4 times x plus h plus 7. Right, that is the first piece excuse me, of the difference quotient. All right, the next piece, we're supposed to subtract this g of x, and that part's easy because g of x is just exactly what we started with. So 3x squared minus 4x plus 7, all divided by h. So that's the setup piece, and this is kind of the toughest piece to get because of that tricky function notation. But from here, all we have to do is simplify. Now, on the first piece from the g of x plus h, we've got some stuff to distribute, right? So the squared here, we're going to have to FOIL that quantity. At some point, we're going to have to distribute the 3 in, and we're also going to have to distribute the negative 4. Another thing to comment on, notice that when I subtracted the g of x here, I had to put big parentheses around that. If you don't do that, then when you subtract, you'll only end up subtracting the first term, and we really want to subtract this entire quantity. So be careful that you're subtracting the whole g of x. Okay, so I'm going to FOIL this out. I have 3 times. My FOIL, I first have an x squared, plus, and then I have an x times h, and then another x times h, so 2xh plus h squared, there's my FOIL, minus, I have to distribute that negative 4, so that's a minus 4x and a minus 4h, don't forget the negative, plus 7. And then I have to distribute the subtraction here, so I have a minus 3x squared plus 4x and minus 7. And this is all still divided by h. Okay, so I've got some distribution here. Now the next step is going to be to multiply in this 3, but I actually already have some terms that cancel. So right here I have a negative 4x that will cancel with this positive 4x, and then I have a positive 7 and a negative 7. Okay, so distributing the 3, I've got a 3x squared plus 6xh plus 3h squared, and then the minus 4h, and then minus 3x squared, all over h still. Now again, we have some more things that cancel. The 3x squareds will cancel, and everything else doesn't have any like terms, so that's kind of where we would stop on the top. However, you should notice that we've got this h on the bottom, and there is a common factor of h on the top. So we need to actually factor out h from all of these terms. So on the top I have h times, this would be a 6x plus 3h, right, I've taken one h factor from there, minus 4. If I factor the h out of 4h, I get just the 4. On the bottom we have h. And now the h on top and bottom just cancels to become a 1, and we have our result, which in this case is 6x plus 3h minus 4, and that is our final answer.